where are we on material? People have questions we want to ask them last week. Do we want to go on? Homework questions? I think so. Didn't I post the book Solutions online already?
They're up.
They're up? Yep, so I think under course documents maybe, those are the lectures and the last course of assignments. There are the assignments that we've had, and I have put up the solutions to all of the, I put up the solutions to everything. And I think I put up in a folder the homework as well. Book homework is old homework solutions.
Yeah.
Which hopefully are right.
I was going to say, are you certain about number 14, part D?
Number 14,
In
chapter 1,
chapter 1.
part
Yes, I get. Yeah.
B, the multiplication of matrices.
Is it big D?
D, the transpose, and then the multiplication of the matrices minus the multiplication of the transpose.
Because the answer, I guess, differs in row 1, column 1, and row 1, column 2, but it's identical everywhere else. I can't figure out why.
Row 1, column 1, and row 1, column 2. Well, shouldn't you get 0 if you multiply two matrices and subtract the multiplication of the transpose? So the transpose would, I mean, it makes sense to me that I have all zeros down the diagonal.
Yeah. I just didn't actually get it.
Well,
Maybe I
you know, that's what Maple's for.
Yeah.
I mean, you know, your calculator. All right, yeah. I don't want to go through that, but if you really want me to, I will get out Maple Mathematica and do it, but I don't want to do that now because I'm just as likely to make a mistake if I do that by hand now as I would otherwise.
I'll ask Max.
Yes, that would be perfectly fast. Other questions, people have? Seriously, you guys don't have any questions from last week? I should leave more off.
Number 28. And
From
chapter 1.
chapter 1. Okay. So, we have to take gradients in R-like things, and it's best to do in non-Cartesian coordinates, right? So if you look in Appendix F of your book, there are the rules for taking gradients, and curls, and Laplacians, and divergences in non-Cartesian coordinates. Those of you who have had E&M have understood already that to take you should be able to take a gradient or a divergence in Cartesian coordinates, XYZ coordinates, just because you know how to do it. Okay? You shouldn't have to look that up. Okay? On the other hand, in spherical coordinates or cylindrical coordinates, nobody knows the formula. Okay, so it's trained monkey work. Okay? So in our book, in Appendix F, are the instructions for how to take the gradients and curls and all these sort of things in non-Cartesian coordinates. Yep, see, it's in Appendix F. In the E&M book, it's in the front cover, which is even more convenient. All right, so if you ever go ahead and buy Griffin's the E&M book, I mean, you might as well. It's going to be the book we're going to use for E&M. It's in the front cover. So what you do is you look up how to do it. So in 28, just 28? Guess what, 28, right?
Yeah, I'm just confused because I don't know. It's R vector, right?
Yeah, so R, ooh, what did they do there? Oh, what the hell is that? Oh, I lost magnets. Oh, no. Yeah, okay. So it's the problem says to take the gradient of the log of the magnitude of R vector. So there's horizontal lines around R vector, which means the magnitude of R vector. So it just means R. So the formula in appendix F, equation F9, is that the gradient in spherical coordinates is r hat times the derivative of the thing with respect to r. So I remember that by looking it up. Okay? And then there are other terms like the derivative with respect to phi and the derivative with respect to z. Those aren't there. There aren't any p's and z's, so I just take the derivative with respect to r. And so the derivative of the log is 1 over r. I multiply by the r hat because that's in the instructions. E sub r means r hat in the book. And then I wrote it as r vector over r squared because r hat is r vector over magnitude of r. Well, I wrote it that way. I don't know why I did, but.
Because that's what it wanted us to show. R vector over r squared.
Yep, that's why I would have done that.
And then you just have to recognize that, yeah, r hat is
Yeah.
r vector
Now you
over r.
could do this in Cartesian coordinates, but it would be hard.
Yeah, you can.
Okay? You take the x derivative, multiply by x hat, and the y derivative, multiply by y hat, and the z derivative, multiply by z hat, and then regroup it all up. Actually, it wouldn't be that bad. And you would get that. That make sense? And then I asked you I should do 31, which also you should do in spherical coordinates and not Cartesian coordinates. Because to do 31 in Cartesian coordinates would be off. So you look up. Like that. People good? Yeah.
I have a question from you two.
Yep.
In your solution, for question number 3.
E2 16.
Yeah.
I and B.
Question 3.
Okay.
In your solution, you went through it, and at the end you said that there was an anti-symmetric and then a symmetric part.
Yeah.
And I don't know if you've already addressed this with the cross, but I was wondering what that was about.
Yeah, all right. So I will answer this by saying that I would never test you on this. Okay? And the idea is that a symmetric thing is something which is a matrix, A11 and A22 are equal. And an anti-symmetric thing, which is something that, like a matrix, A11 is minus A21. So there's a minus sign in there. And when you multiply those two types of objects by each other, and then add them up in a particular way, you get 0 when you do that. It's just one of those things that you get, that you learn to recognize, but we're never going to do it or talk about that again in this class. So it's not going to come up. The reason I'm not going to test you on this, the index stuff, I'm not going to test you on the index stuff, okay? It's not going to come up again. It's something that you kind of should get exposed to when you go to graduate school. The professor will start writing it up on the board, and then you'll really have to think about it. And if you go work in industry, never going to come up. Okay, so
we're not going to be tested on the index.
no.
Okay.
Not gonna touch on it.
So is there a way to solve that without considering the symmetric and
Well, you can write all the shit out. Yeah, I mean, you can A cross B. The x component of A cross B would be AYBZ minus AZB x, BY. Then you multiply that by AX, because that's what A dot that would mean.
Right.
Then you'd have AY multiplied by AZBX minus BZAX, which I just got signed backwards and said the wrong thing. And then you multiply AZ by, and you get 6 hideously long terms that each had an X, Y, and Z component. And then they'd all cancel out. And they'd all add up to 0. And if they didn't, then somewhere along the way you wrote an X subscript when you meant to write a Y subscript. Which is good training for being careful. It is important for those of you who are just coming out of your 244 experience to learn that you now are required to be careful. Right? You have to actually be able to do algebra now. Even if it's like a whole page worth. And your professor every now and then cheats and just says, oh, it's different. Because your professor has done it at least 3 times. Okay, so I've done it at least 3 times, Stephanie's done it at least 3 times. I can prove the back half rule. People know the back half rule, right? A cross B cross C is equal to B times A dot C minus C times A dot B. You know, you have to write all this out at least once in your life and prove it yourself, and then you go, I can do that. Big belt.
Remember, you're on camera.
Yeah, so, part of the act, right? Okay. Other questions people have?
Part the animal body.
Chapter which?
Chapter 1.
Alright. Oh yeah, hill. Let's talk about that. That's actually really important.
I like the first part of that. I like the second part.
Alright, so we have a hill given by z is 2xy. Are my solutions wrong with this problem? 3x squared.
Oh, no, I think they're right.
They're right.
Okay. I agree with the first one, the first part. Pretty one.
Alright, so here's z. So I'm going to define f to be all of this stuff. Copy. Paste. Minus z. So I'm going to define some f to be that. And the reason is that technically f equals 0 is the same thing as this hill. Does that make sense? Z is equal to all that stuff. So all that stuff minus z equals 0 is the same thing. Now the gradient of that points perpendicular to the hill. So the gradient of that, I can take the derivatives, right? So let's see here. I have x hat is 2y minus 3x minus 18 plus y hat is 2x minus 8y plus 28 plus z hat times negative 1. Yes, it would. Right? And so, and my z hat, that is negative 1 here. Yeah, I guess I'm okay with that. Am I okay with that?
I think the solution you define it as z minus stuff instead of stuff minus z.
Yeah, that's fine. That's not a big deal. So the top of the hill, I would need 2y minus 6x minus 18 to be equal to 0, and 2x minus 8y plus 28 to be equal to 0. And the solution is, survey says, what's the solution? What is it? X is
X is minus 2, y is 3.
y is 3. Okay, so, you know, algebra to there. Okay? So the top of the hill is where there's no x or y slope, which means the normal to the hill surface points into the hill. Does that make sense? So my vector here, at these points, x hat component is 0, y hat component is 0, and so my normal to my hill points straight down into the hill. So it's flat. Okay. And then it says, how steep is the hill at 1, 1? So I would put in the values. Oh yeah, that's kind of a clever question. So here's A. So B, at 1, 1, and whatever Z is, then I can figure out how steep the hill is. So at 1, 1, the gradient of F is, let's see, 2 minus 6 minus 18 is negative 22. And 2 minus 8 plus 28 is 18? Is that right? Come on, that's not right. 22. So here's my gradient vector, and I want to find, it says, the angle between a vector perpendicular to the hill and the z-axis. So here is the vector perpendicular to the hill, right? So the vector so I know the, okay, so del dot f, that's not right. Gradient of f dot z hat is -1. Everybody agree? You good? Why the hell am I, all right, are people confused about why I'm doing it, or are people confused about what I just did? Okay, so here's the gradient of z, or the gradient of f. So I'm going to take that dot z hat. Well, z hat dot this is what? 0. Z hat dot that is what? 0. Z hat dot that is -1. And that's got to be equal to the magnitude of the gradient of f, the magnitude of z hat, times the cosine of the angle. Which is what I'm trying to find. So the definition of the dot product is multiply the two dot products by x hat and x hat terms plus y hat, y hat component plus z hat component, z hat component. And that's equal to the magnitude of one, magnitude of the other, square root times cosine theta. Cosine theta is what I'm looking for. So -1 is equal to, okay, so this thing's 22, 22, 1, right? So roughly it's 22 times the square root of 2, but I can work it out, right? And the magnitude of the vector is 22 squared plus 22 squared plus 1 squared square root. Everybody good? What?
31.12.
31.12? Okay. Did I get the answer right? That is. Yeah. So that's 31.1, say, times 1 times cosine of theta. So theta works out to be 88 degrees. So the vector is coming in, so the vector's coming in like this, right? So here's the normal, excuse me, here's the vertical direction. And my vector gradient of f is coming in like this, so the hill's going down like that. So there's a right angle there. Damn, that camera's bothering me. Alright, so anyway, you got something. You okay with this? Sort of makes sense? Good? Alright. Other questions we want to answer? Let's do air resistance. Air resistance?